In this video, I'm going to show you how we can create a Venn diagram to organize information. And I'm going to do 3 examples and focus on Venn diagrams where there are 2 circles, and then I'll do a separate video on 3. And so in this first example, we have a survey of 55 randomly selected swim team members. 35 like freestyle, 25 like backstroke, and 18 like bowls. So if you're reading a problem like this and you're not sure, you really want to, not sure on how many circles there should be, you really want to look at the different categories there are, and if there are 2 distinct categories, that tells you you should draw a Venn diagram with 2 circles. And so I'm going to start by drawing the diagram before I answer any questions. And so I'm going to do 2 circles. I'll call this one freestyle for F, and then I'll label this one B for backstroke. And then what I want to do is I want to use the information given. So look at all these numbers and figure out what number needs to go in every part of the Venn diagram. So there are 4 parts, here, in the middle, here in backstroke, and then on the outside. So unfortunately, we're not always given numbers that can go directly into the diagram. Sometimes we have to do a little work before we do that. One thing that can sometimes help is just to take all the information in the problem out of the paragraph and make a list. Some people find this helpful, and so I'm going to do that over here. So we have a total of 55 members, and then for freestyle, we said 35 like freestyle, backstroke 25 like backstroke, and then both 18. And one thing we can notice here is that this both number 18, that can go directly in the diagram because the intersection between the 2 sets, which is right here, this represents what both people liking both freestyle and backstroke. So that 18 can go directly in the diagram, which is nice. So I'm done with that one. Then I go to backstroke. So 25 people like backstroke, but 18 are already in that circle. And so to figure out what goes here, what I need to do is take 25, which is the total backstroke, and I'm going to subtract the 18 that are already in the circle. And that gives me 7 left over. So if I put a 7 here, you can see that 7 and 18 together, that's 25, and that's the total in the backstroke circle, which is what we want. And I'm going to do the same thing for the freestyle circle. So let's see, so 35 should be in that circle, and 18 is already in it. So we're going to take off 18, and if we subtract, we get 17, and so 17 should go here. So 17 students or swim team members only like freestyle and not backstroke, 18 like both, 7 like backstroke but not freestyle. And then if you add these numbers, they actually don't add to 55. So if you're wondering, well, where's the rest? Well, the rest go on the outside of the box, swim team members that don't like either freestyle or backstroke. So what we're going to do to find that number is we're going to take our grand total and then subtract all the rest of the numbers. So 17, 18, and 7. And if we subtract all of those, we end up getting 13. And so 13 swim team members don't like freestyle or backstroke. And another good thing to do before you move on to answering questions, this is quick, it's worth it. Add all the numbers up, 17 plus 18 plus 7 plus 13, and see if they equal 55, which they do. So that's just a quick check. Now that we have the diagram drawn, now we can answer questions. So A says, how many members like freestyle or backstroke? Well, the word or means they could say yes to freestyle only, backstroke only, or both. So what that looks like, it looks like the union of freestyle and backstroke. So it's all of freestyle, all of backstroke, and then you can see as I shaded those circles, it automatically shaded the center. It's a little bit hard to see now. Here, I'll make it a little darker. And so the numbers that we want to add to answer this question for freestyle or backstroke are 17 plus 18 plus 7. And that gives us 42 members total. And then for B, we're asked to find the percentage of the team that likes freestyle or backstroke. So the same question as A, except we want a percentage answer instead of an actual number of people. So all we have to do to find a percent is just take the part divided by the whole or the total. So if 72 people not 72, 42 members like freestyle or backstroke, we can just divide that by the total, which is 55. And then let me bring up my calculator because this problem says round to the nearest tenth of a percent. And so the first thing that we're going to have to do is divide and figure out what the percentage is first. So you round last. Okay, so when we divide these two numbers, we get the decimal point 0.7636363664, and we need to convert to a percentage by moving the decimal 2 spots to the right. You could also just do times 100 in your calculator, and so we get a percentage of 76.3636. It keeps on going. Now we can round. So we're going to look at the tens place, which is right here. And since there's a 6 next to it, that bumps up to a 4. So our answer here should be 76.4% of the swim team members. All right, so let's look at example 2. In this example, we have a wooded property with 59 total trees. So I'm just going to write down total is 59. 5 trees are evergreen and over 20 feet tall. So right there, that tells me, okay, I've got 2 different categories that are introduced. So I'm thinking that it'll probably be a 2-circle diagram, but we don't know yet. So I'm just going to jot that down. So evergreen and over 20 feet tall. So I'm going to say E and O. Evergreen is going to be my E. And over 20 feet tall, we're going to say that's O. So evergreen and over 20 feet tall, we have 5 of those. 35 trees are not evergreen and are over 20 feet tall. Okay, so we've got not evergreen and over 20 feet tall is 35. And then 4 trees are neither evergreen nor over 20 feet tall. So neither E nor O is going to be 4. And so I don't see any other categories here. So this tells me that my Venn diagram should have 2 circles. So I'm going to draw my Venn diagram, and I'm going to draw a circle for evergreen and then a circle for over 20 feet tall. And so I'm going to go through my list and see which numbers I can put in the diagram. So my total, that should be all of the numbers added up together, should be 59. So I can't do anything about that now. Evergreen and over 20 feet tall. Well, that tells me the intersection, so the both number. Okay, so 5 trees are evergreen and over 20 feet tall. So we put that in the middle. So we got that one done. Okay, not evergreen, so that means it shouldn't be in the green circle, and over 20 feet tall. So we're talking about this section right here, there should be a 35. So just again, this is not evergreen, it's outside of the green, but it is in the over 20 feet tall circle. So that's nice. I didn't even have to do any subtracting like the last problem. And then neither evergreen nor over 20 feet tall, that means it needs to be outside those circles is 4. So 4 trees are not in either of those circles or categories. So we're missing just this section over here, evergreen but not over 20 feet tall. So one thing we could do to find this, we have this missing, number, is we could just take our total, which is 59, and we could subtract 5 and subtract 35 and then subtract 4. So take off all of the numbers that are in the Venn diagram already, and if we do that, we end up getting 15. And so we're just going to put 15 here. And like I recommended with the last problem, just before you answer the questions, add 15 plus 5 plus 35 plus 4 and make sure that it's 59. And I did that check and it is 59. So that tells us that we're on the right track. So now let's go ahead and answer the questions. So for part A, how many trees are evergreen and below 20 feet tall? So keep in mind this circle right here is over 20 feet tall. So if we want to know the trees that are evergreen and below 20 feet tall, we could even rewrite this as not over 20 feet tall. So in the evergreen circle, but not part of that over 20 feet tall circle. So we're looking at this number 15 right here. So for part A, it's going to be 15 trees. For part B, how many trees are evergreen? Well, we're looking at the entire green circle. So it has a 15 and 5 in it. So I'm going to take 15 plus 5 and I get 20 trees for that one. And then for C, how many trees are over 20 feet tall? Well, that's the O circle, so it's going to be the 5 plus 35, and that gives us 40. All right, so we're going to look at one more example. In this example, the last example, we're going to use a formula for cardinality of a union for two circle Venn diagrams. Let's go ahead and read the problem, and then I'll come back up and explain why we would even need this formula. So out of 35 people in the room, so that looks like a total, so I'm just going to jot that down. So we have 35 people total. 13 are wearing black shoes, so that looks like a category. So black shoes. We're going to say 13, and 16 are wearing a black shirt. So black shirt, we have 16. 10 are not wearing any black at all. So that would be like neither. So no black, that means no black shirt, no black shoes, and so I'm going to put a 10 there. How many people are wearing black shoes and a black shirt? So before we try to answer that question, let's see what the Venn diagram would look like. So we have two distinct categories, black shirt and black shoes. So I'm going to draw two circles. We'll label this one black shoes, and then the next circle, black shirt. Okay, so let's go through our numbers and see if we can put any in the diagram. So our total, we always say that for last. Black shoes, that's the entire red circle, needs to be 13. The hard thing is though, is we don't know where that 13 should go. Should it go here? Should it go in the middle? Should it be broken up a little bit in each section? We don't know. Same with black shirt. So 16 is the total for this entire circle, but we don't know how much is in the center versus how much is over here. Now, no black at all, that means people that are outside of this. This is outside of both of the circles because they don't have black shoes or black shirts. So that number I can put on the outside. So I'm going to write a 10. So at least we get to put one number on the outside. And the question asks us, how many people are wearing black shoes and black shirt? So this right here is what we want to know. Right now, without anything else, we can't answer this question. So this formula up here can come in handy because it basically just tells us if you want to know the small n just means the number of elements. If you want to know the number in A union B, which is all of this, like the green and the red circle together, then you just take the number in the one circle, the number in the other, and then you subtract the intersection. So this right here is the intersection. And this right here, the union is A and B combined together. Okay, so I'm going to write down this formula because it's going to be helpful for us. So the number of A union B is the n of A plus n of B minus n of A intersect B. And I like to even write this again, only instead of A and B, we could call it black shoes and black shirts. So the number of black shoes combined with, actually I shouldn't write it like this because I'm going to have the same letters. So let's try this again. We'll say the number of black shoes combined with black shirt is the number of black shoes plus the number of black shirts minus the number of black shoes and black shirts. Okay, lots of writing, I know, but I'm telling you, it's worth it to write it out sometimes so that it can make a little bit more sense. So now what we can do is figure out, okay, which one of these numbers do we know? We actually know quite a bit of these. So one thing we can do is we can find the union because the union is all of the red and all of the green, and it's just going to be the number that's left over when we take the total and subtract the 10. So if there's 10 on the outside and there's 35 total, it means there's 25 altogether in both of these circles. So just, to back that up, if we want to find the number of black shoes and black shirts, all we have to do, that union, is we take 35 minus, which is the total, minus the 10 that gives us the outside, or the 10 is the outside, and that tells us that 25 needs to be the total of all the red and all the green. So that way, when you add all of that up, 25 plus 10, you get 35 total. So for the number of black shoes combined, or union black shirt, that's going to be 25 equals the number of black shoes. Well, we know that it's 13. That entire red circle should be 13. Plus the number of black shirts, well, 16, minus the number of black shoes and black shirts. That's our x that we don't know in the middle. So I'm going to say minus x. And then from here, we just have an equation. So we take 25, we add 13 and 16 together, and we get 29 minus x. Okay, and then we can move things around a little bit. I'll add x to both sides. I'll get it over here so it's not negative. So x plus 25 equals 29. And then I can take off 25 from both sides, and I find out that x is 4. And so 4 is in the middle. And then at this point, if you had other follow-up questions, which we don't, but if you did, you could take the 4 and then work your way backwards to fill out the other sections of the Venn diagram. So if this is 4, if we know that 13 needs to be the total in the black shoes category, then all I have to do is 13 minus 4, and that gives us 9. So we know there's a 9 there. And then I could do the same thing over here. For black shirt, if 16 needs to be the total and 4 is already in the intersection, we could take off 4, and that gives us 12, and we can put 12 there. So, and like I said, we didn't have to do that for this problem, but sometimes, you'll see problems where there's several follow-up questions, and that could be helpful to fill out the whole Venn diagram.